Good morning all. In today's session we talk about the data normalization. Normalization is defined by NF, like NF is a word, so it's have the levels. So we check about all the levels, but normalization means the data put it into more RDBMS format. RDBMS means relational database management system. So that way it can get easy to manage and easy to modularize. So we'll check in a today's session what is meant by normalization, why it's required, and how to normalize the data with a simple example. So basic about the normalization to reduce the data duplicacy and eliminate the undesirable anomalies. Means if you suppose you have the multiple duplicate data in a one table, like we have 3 table, okay, all the unique combinations are we are duplicating all the data in a 3 table, suppose, and these are the interlinked the table. Suppose there are then very high chances that some data is deleted from here, but data is present here. So this is a case of anomaly. So we'll create a such tables. Out of this we'll create a 1 2 3 table. Out of this whatever data is a common we are putting at a one place and map this with the, this is a fourth master table, and update with the IDs only. So in this case the anomalies won't come. So how to do that we'll discuss, but that's the main way. Suppose if you are replicating multiple 4 columns which are duplicated 4 4 4 and each required 10 byte, that means 10 into 40 so 120 bytes you are wasting per row in this 3 table. So you can easy to save that data size also in this, just preparing a one table. So that is way the data reduplicacy and the eliminate the anomalies like this. That's the main motive behind to do data normalize. Apart from that, smaller table, like we discuss here, like the data is duplicated, so just preparing a one table that also get rid of multiple data which is not required in a duplicate form, and we are linking 1 2 3 table with the 4 table. Okay, that's the way of a normalization. Okay, and data is stored more in a logically, like 1 2 3 is a duplicate data, that's why we pull all the duplicate data, prepare one table, and whatever functionality of 1 2 3 will kept into these tables, and that's why logically grouping happen here. So common data placed at a single place and operational data placed at an operational table, like operation 1, operation 2, operation 3. Okay, that's the basic intent behind the normalization. Means what is the normalization and why normalization required. We'll check about the how we are doing the data normalization. Okay, yeah. So in the next part we'll check about the data, like real example, like this is our data, like we have full name, physical address, movie rented, and the citation of the name. Okay, these are the our data. Consider this data like John's have the address, but he rented a 2 movie at a time, and the Robert who have rented a 2 movies, like Forgotten Sir Marshall and Daddy's Little Girl, 2 rented, and then Robert will another have a different address and he buy 2 different movies. Okay, so at a first normalization there are 2 rules which need to follow. This is our raw data. Okay, so after applying a normalization rule, that become a 1 NF, 2 NF, 2 till 6 NF. Okay, you can do the normalize. Okay, at a first there are rules like single value per column and per row you should identify as a uniquely. But here we have different data. 2 rows can be built out of these, 2 rows we can build out of this, and this is a 1. So total 5 row we can pull out of this. So after applying one normalization form, 1 2 3 4 and 5 rows we all pull out. So that means our data from raw data to one normalized form we achieved. Okay, in a second normalization form there is a rule which says that not functionally dependent on any subset. Currently our subset, like if you check, like member ID and the rented movie are correlated with each other, because we have the member, okay, member data and the movie data. 2 are the different entities. Movie is a different entity and member are a different entity, because one member have the multiple link with the movie, and one movie means one member can buy the multiple movies. So that relation if you check, that means you can segregate the data in a more structured manner. So in a second normal form, not functionally depend on any subset. That means member and movie 2 different entity, and when we are splitting that into 2 different table. So if you check here, earlier whatever data we have, we are segregated with the member ID, because only 3 are unique thing. Means Jen Jones is a 1, Robert Pill added second member, and the Robert this is the Robert Pill, and the address are getting changed. So this is the Robert Pill, third Robert Pill is there with the different address. So uniquely identify these 2 column, like full name and physical address are uniquely identified. So 3 rows, and out of we have 5 movies, 1 2 3 4 5, all are the different. So we created these 2 table out of this. So second normalized form is achieved by doing that. Okay, so next is the third normalized form. Here most of the practical applications are here, and 99% IT companies whichever we are working, or whatever questions you are asking in interview, that till level, like provided your raw data and they ask to move to the normalized form and till 3 normalized form. Okay, So we already segregate between a member and movie. Two are the different entity, and we segregate earlier and previously. That we are checking with the entity, but here transitively functional dependency also not with each other. Okay, that's why we are depending. Transitively dependency means, okay, if you check here that Mr. and Mrs. is the salutation, and we are defining the here also duplicate data. Mr. is only two things and Mrs. is a one row. So here also we can do transitively remove the transitively dependency from this. Okay, so here what we did, we create a one table with the salutation. So earlier member have the salutation, but this is also duplicate data. So out of member we are created with the salutation table, and in that salutation put that. So this is linked with the member, and this is linked with like this, like member have the movie and member have the salutation. So this is, we build a 3 entity. So till now we achieved a max like 3 NF as per the industry, but there are multiple normalized from, like we can do at a very granular level. But whatever example we took, that's the very simple example, so we cannot divide further. But a similar way in a this is a bicod normal form, which is considered as a 3.5 NF. So here anomalous result, then we are adding one more candidate key and we are splitting the table. Same we do with the 4, 5 and 6 level. Till 6 level maximum complex data try to drill down into very simple form. That's why highest level is a 6 binomial form. 6 is a normalized form, but till the 3 we are good on that. Okay, till now we discuss about the normalize, how to do that. But what is the takeaway from this session? Okay, first is a normalization help to reduce the produce the database cost efficient and have a better security. Cost efficient, what? Because data duplicacy get reduced, so size become also reduced. Apart from that, the query performance also get better. So that also we are seeing two-way benefit we are getting. First way, database size, capex size, data size get reduced, so capacity expansion get also reduced. Apart from that, operation cost also there. So one query took 10 minutes to execute. After doing normalization, that become very less. So that's also another benefit we are getting out of it. And the clear functional dependency we are getting currently. Earlier data is very complex in a raw data form, but in a today's example, if you know that we have the member, out of that member have the salutation, one to multiple mapping is there, and member have the movie. Okay, so movie. So here we can easy to define one member have the one salutation, but one member have the multiple movies. This is the relation diagram you can put, and clear definition. Okay, most of the database is on a third normalized form. We already discussed. Primary key unique key identify the record in the table cannot be null. This is already help us. And foreign key define the relation between, means salutation ID is a part of this. Salutation ID is a primary key here. The member ID is a primary key here, but it's a part of a foreign key in a salutation. And similar way, member ID is a primary key for here, but it a parts of a foreign key here. Okay, so in a whole databases, primary key is the member ID. Okay, member ID. Yeah. And this member ID is the foreign key of a salutation table and movie table. So that way mapping is done. Okay. Yeah, that's the takeaway from today's session. If you have any questions, any doubts, let me know. We'll discuss in upcoming sessions. Yeah, thanks all. Bye.